friends due to unforeseen conditions. So today we will be continuing sessions. So we'll start with the sessions. I'll give you 3 minutes to solve the questions. Please take 3 minutes to solve the question. Time. Please post your answers. There are 4 people who have posted the answers, and all the 4 of them have got option C. So let's see how to go about how to solve this question here. So the question says, what is the smallest number greater than 1000 that when divided by any one of the following numbers, 6, 9, 12, 15 and 18, leaves the remainder of 3. So that number would be the LCM of 6, 9, 12, 15 and 18 plus 3. So that number would be the LCM of this plus 3, and that LCM should be greater than, and that number should be greater than 1000. So to find out LCM, I'll just write these numbers in prime factors form. 6 can be written as 2 into 3, 9 can be written as 3 square, 12 can be written as 2 square into 3, 4 3s are 12, 15 can be written as 3 into 5, and 18 can be written as 2 into 3 square. So the LCM will be 2 square into 3, base power of 3 is 3 square, and then it's 5. 2, 3 and 5. Base power of 5 is 5. This is 4 into 9 into 5. So 9 5s are 45. 45 into 4 is 180. And to find out the nearest number that is greater than 1000, just greater than 1000, that would be 180. Let's check into 180 into 5. That will give me 900. So the number just greater than this thing is 180 into 6. This is 180. So this should be the multiple. I mean, since it should be now greater than 1000, so it should be a multiple of LCM which is greater than 1000. That is 1080 plus 3. Correct answer is option C. I hope this is clear. If you have any doubts, please ask. Or if everything is clear, we'll move to the next question. We'll move to the next question then. Take 3 minutes to solve this question. So around 1, 2, 3, I mean, most of them have got option A. Now some people are getting option D. We'll see how to go about this question. Sita and Geeta go for a swim after a gap of every 2 days and every 3 days. If on the 1st January, both of them went for a swim together, when will they go together next? So if today is first Jan, they are going to, they are going to the swim together on 1st Jan, and then they are asking when will they go again. So, and there's given this data here. Sita and Geeta go for a swim after a gap of 2 days and 3 days. Sita goes after 2 days. So she won't go on 2nd, won't go on 3rd, would go on 4th. So Sita. And Geeta goes every 3rd day. So after a gap of every 3 days. So 1, 2, 3. This is Geeta. So if we see here, Sita is taking every 3 days. 1, 2, 3. 1, 2, 3. Sita is taking 3 days. After 3 days, she is going for the swim. And Geeta is going after 4 days. So they would go together again on the LCM of 3 and 4. That is 12. So after 12 days, they'll again go for the swim. So on 1st, if they're going together, then after 12 days, that is on 13th, they'll go again. So the correct answer is option D. People who have done, who have got option A, they have just directly taken 2 and 3, and they've taken the LCM of 6 days, and then they've added 6 days to the first day, and they've got 7. But it's they are saying that they are going for the swim after a gap of 2 days. So they're not going on 2nd, they're not going, Sita is not going on 2nd, and Sita is not going on 3rd, but she's going on 4th. So that means after a gap of 1, 2, and 3 days. So that is 3 and 4 days, and the LCM is 12. Hope this is clear. Please ask if you have any queries, especially people who have got option A. Is this solution clear? And have you realized what is the mistake that you have done? Sure. Then we'll move to the next question. So take 3 minutes to clear. Solve this question. How to go about this question? The question says that a certain 3-digit number have following characteristics. All the 3 digits are different. The number is divisible by 7, and the number on reversing the digits is also divisible by 7. How many such 3-digit numbers are there? So just like our normal way, let's consider the 3-digit number as ABC, and the digits, when you reverse it, will become CBA. And they're saying that this number, these numbers are divisible by 7, and the number on reversing the digits is also divisible by 7. So let me, this can be ABC, and CBA can be written as 100A plus 10B plus C, and this number CBA can be written as 100 into C plus C. So they are saying when you reverse this is a multiple of 7. We take this as P, and this is 7Q. And when you subtract this, when you subtract 2 multiples, we had discussed it in the this thing, initial basic classes. When you add or subtract 2 multiples, you would get a multiple. You would get a multiple of the same number. For example, 7, 14, 21, 28 are the multiples of 7. And if you subtract add of any one of this, for example, 21 plus 14 plus 5, 35, this is also a multiple of 7. And if you subtract it, this is 7. This is also a multiple of 7. So if whenever you are dealing with 2 multiples, if you add or subtract, you would get a multiple itself. That thing that I have used here, this is a multiple of 7. and subtracted a multiple of 7. So you would get a multiple of 7. And here, by doing that, I have eliminated B here. So this becomes 99 A minus C is equal to 7n, because this is multiple of 7. And now, this case, A minus C, in this 99 is not a multiple of 99 is not a multiple of 7. Multiple of 7. So A minus C would contribute. A minus C would be multiple of 7. Multiple of 7. So only then this whole number can be a multiple of 7. And A minus C, or A and C, are single digit numbers. So these numbers can be from 0 to 9. A and C can be are only between 0 to 9, and the difference should be a multiple of 7. So that difference can be, here in this case, can be the difference is 7. So one number can be 8 and 1, 9 and 2. If you take 3, you would get a double digit number. So the numbers would be, so A can be is equal to 1, C can be 8. So I have the original number, that is ABC. I still don't know what is B, but I have A and C. But in this case, I have, let me take this as 1, B and 8. And according to the divisibility rule, when you multiply this number into 2 and then subtract it with this number, you should get a multiple of 7. So to find out B, what I'll do is I'll take 8 and multiply by 2, it will become 16. And 1B minus 16 should give me a multiple of 7. So in this case, the only possibility for B would be 16 or 6. B can be 6. So one number, which is a 3-digit number and divisible by 7, is 1, 6 and 8. And if I multiply, if I reverse this, this will become 8, 6, 1. So both these numbers are divisible by 7. Divisible by 7. So next case is when A is 2, B we don't know, and C is 9. So here again same, what I'll do is I'll multiply this by 2, 9 2 is 18. So 2B minus 18 should give me a multiple of 7. So in this case, B has to be, I need a 7 or 14. The difference cannot be 0. It should be 7 or 14. It cannot be 14, because this number cannot be more than 9. So the only option is B can be 5. 2 plus 4. And if you subtract 25 by minus 18, you will get 7. So B is 5. B is 5. So another possibility is 2, 5, 9. Further, if you reverse it, it will become 9, 5, 2. Even these two are divisible by 7. So the total numbers are 1, 2, 3, 4. 4 numbers. I hope this is clear. So the answer is option B, 4. So there are 4 3-digit numbers which satisfy these conditions. I hope this is clear. If there is any doubt, please ask. And people who have not got this, the answer for this, 6 and 5. Okay. See, according to the rule of divisibility, I had discussed one rule where if a digit ABC is divisible by 7, you have to double this digit and then subtract it with the remaining digits from A, for example. Or else what you can do is, so AB minus C in this rule should give you, the difference should give you a multiple of 7. Multiple of 7. This was the rule that we had discussed in the basic sessions, first intro sessions that we did. So similar in the same way, for example, in this case, this was 1, 1B and 6. This was a 3-digit number. I'll just write it in different color. So 1B and 6 was there. So in this number, I have, this is not 6. 1B and 8. 1B 8 was there. So this number I had to double it. So 1B minus 16 should give me a multiple of 7. So multiple of 7 here can be 0 or 7. But this B can, the maximum this number can be 9. So the difference cannot be 9. But if you make it, if B becomes 6, then this becomes 0. 0 is technically a multiple of every number. So 0 is a multiple of 7. So to make this 0, I have made B 6. So the number would be 168. And the other number is here, 2B, this is 2B9. Now this, if I multiply this digit into 2, that is 18, and I have to subtract this 2B from this 2B, I have to subtract 18 from this 2B. And to make this number multiple of 7, B should be 5. If B is 5, 25 minus 18, this becomes 7. For any other number, this cannot be a multiple of 7. So when B is 5, this becomes 259. And when you reverse this number, this is 952. For example, even 952, you double this number of 2. You want to check the divisibility. What you can do is double this number. 2 into 2, 4. Subtract 95 minus 4. You'll get 91. 91 is a divisibility. Is a number divisible by 7. 7 into 13 is 91. I hope this is clear. If you have any doubts, please ask. We'll move to the next question then, if everything is clear. So take 3 minutes to solve this question. 3 of them have got option A and 1 has got option D. We'll see how to go about this question here. We're saying that a 2-digit number is reversed. The larger of the two numbers is divided by the smaller one. It is the largest possible remainder. See, whenever you want to find out, what is remainder? For example, if 9 is divided by 2, the remainder would be 1. Because 9 can be written as 2 into 4 plus 1. So this number, they are asking what will be the largest possible remainder if you use a 2-digit number, AB, then you reverse it, BA, and then when whichever is largest would be the numerator, AB, and if you divide it by the lowest number, smallest number among these two, the remainder that you get should be the largest. So when would you get the remainder largest? For example, if you are taking, the number has to be somewhere in the 90s. Why? Because 90s is the largest in the 2 digits number, the largest in 10 numbers that are among the 2-digit numbers. For example, you are dividing something. If this is the number, and if you are dividing something, you take a very small unit, then the remainder would be small, because the remainder has to be less than, for example, less than the divisor. It cannot be equal to the divisor. For example, 9 divided by 4, the remainder that you get, or any number divided by 4, any number divided by 4, and the remainder that you will get is always less than 4. It cannot be equal to 4 or greater than 4. So the remainder will be 0, 1, and 2, and 3. 0, 1, 2, 3 will be the remainders. Similarly, you can take any number. For example, you take 15 divided by 4, you get the remainder 3. 15, 4 3s are 12, 5 minus 2 is 3. The remainder is 3. The remainder cannot be 4 because then it will become a multiple of 4. So in this case, to find the largest possible remainder, what we will do is we want this number to be one of the large numbers, and that number should be at least more than, it should not be a multiple of, for example, if this is the whole number, if I represent the number in the number line, if I make the divisor very small, the remainder will also be very small. So the divisor has to be at least greater than half of it. So if I take 9 numbers with, if I check the numbers with 9, 9 is the largest 2-digit numbers, the 10-digit numbers, 2-digit numbers that we have. And then I have to check whether the remainder is greater than or what the digit is, remainder is. For example, 9, if I take the number 90, so if I reverse this, it will be 9. So 90 divided by 9, the remainder is 0. Then 91 divided by 19. Now in this case, if I take this remainder, 19 into 4, 19 into 4 is 76, 19 5 is 95. 19 into 4, 19 into 4 is 76, 91 minus 76. 5, 9 minus 7 is 20. 91. 15. 15, 1 carry is 15. Then if I take 92, what are the options that we have? 9, 27, 36 and 45. 92 divided by 29. 92 divided by 29. Again, this number is not even close to 92's half. It will always be, it will be less than 29. If I take 93, this will be 93 divided by 39. Again, this number is not close to that. 94 divided by 49. Let's check this. 94 divided by 49, ones are 49. 94. This is 94 minus 49, 14 minus 9 is 5, 8 minus 4 is 45. Is this number there? Yes, this is there. This is the highest number that and the option also. The correct answer would be 45. 94 and 49. I hope this is clear. If you have any doubts, please ask. So what I did was I took that, to become the largest possible remainder, you should have the large number, not the largest numbers, and then you have to divide it by something which is at least greater than half of the number, or else that will be divided by the number itself, half of it. For example, if you are taking, the number is 50, you want the highest remainder, the number should be at least 25 and above, 26. You divide by 50 by 26, you would get a large remainder. For example, in this case, the remainder is 24. So I started with 90, and then I started checking with the 90, 91, 92. When you revised it, 90 became 9 years. And they have said that you have to divide the larger number by the smaller number. 90 divided by 9, the remainder is 0. Then I did 91 divided by 19 because I've reversed it. This gives you remainder of 15. And then 92 divided by 29. Since this is less than half of it, I wanted some number which is more than half of 92. Here 94's half is 47. So this is just greater than 49. 49 is just greater than 47. You are getting a large remainder, 45. The smallest remainder is given, that would be, see, the smallest remainder would be 0. Yeah, that would be 9. Yeah, the smallest remainder would be 9. Or it is 0 itself, 55. Reverse it, it will become 55. Smallest remainder is 0. 9. If both the terms in 2-digit numbers, if both the digits are same, I think if they give the digits are different, then it would be different. Yeah, then it would be 9. Here they are not given any details about the digits, whether they are different or whether it can be same also. I hope this is clear, Tam. If you have any doubts, please ask. Others, if you have any doubts, please post your queries. So the smallest remainder would be 0. If you take two similar, like 33 or 22, to reverse it, you will again get 22. When you divide 22 by 22, the remainder is 0. The smallest would be 0. Hope this is clear. If you have others, if there is any doubt, please ask, or else we'll move to the next question. Okay, we'll move to the next question. It's time. Please post your answers. There are three responses for option D. So we'll see how to go about this question. So a digit n is greater, which is in n, that is greater than 3, is divisible by 3, but not divisible by 6. Which one of the following is divisible by 4? So one of the best ways to do such questions is to take an example and then try out the options. So for example, they are saying that n is greater than 3, but n is divisible by 3, but not divisible by 6. So n cannot be 3 because that is greater than 3. It's not equal to 3. And if 6 multiple of 3, 9, 12. So if, we'll take 9 then. 9 is divisible by 3, but they are not divisible by 6. So, or you can take any odd multiple of 3. If you take even multiple, it will be divisible by 6. So we'll see here, if I take 9, I'll substitute the value here. A is 2n, that is 2 into 9, it is 18. 18 not divisible by 4. Wrong. So 3n and 3 is 27. Again, this 27 is not divisible by b. Not divisible by 4. We are searching for a number which is divisible by 4. 2n plus 4. This 9 is 18 plus 4 or 22. 22 also is not divisible by 4. 3n plus 1. And 3 is 27 plus 1. 28. 28 is divisible by 4. Yes. 7 4 is 28. The answer is option D. I hope this is clear. If you have any doubts, please ask. Is everything clear? Contains previous year's questions only. So if you want to practice, you can refer those. Okay then. I think if there are no more doubts, we'll end the session here, and we'll meet on Monday then. So tomorrow is Sunday. Sunday will be an off. So okay then. If there are no more doubts, we'll end the session. Yeah. Thanks for coming, and have a good night and have a good weekend. Thank you.